And the thing to know is a blank piece of paper. Let me hold this up. We are graphing functions. So let's just put functions. And the graph of them. And I think we're going to look at 4. One of them you're pretty familiar with, the other 2 not so much, but let's just talk about this. And here are the 4. Okay, you've got a function which is nothing more than an equation that looks like this. Do I write it in function? Do they? Sure, why not? I will write it as they do in function. Please understand this. If ever you see this, the function of x equals, I don't know, 2x plus 3. Function of x is the same thing as the letter y. Don't get those confused. Okay? And then we've got the function of x equals x squared. We've got the function of x equals the square root of x. And we've got the function of x equals the absolute value of x. You just need to recognize how the graphs of those 4 different things look different. Okay? In other words, this. First of all, we know this, anytime it looks like this with it's just an x, that, see, this is an x squared, that's a square root of x, that's an absolute value. If it's just an x, even if it was just this, I probably should have just wrote this. Okay, what do you always get? You always just get a linear equation. It's a line. It's a straight line. You know, the function of this, or the graph of this was 2x plus 3. Remember, across the y-axis at 3, had a slope of 2, which means it goes over 2, or up 2 over 1. No, over 2, up 1, yeah. Okay, this is the graph of that. So you know, ladies and gentlemen, if you ever just get a straight line, the x is going to be by itself. It's not an x squared, it's not a square root of x, it's not the absolute value of x. This will become a little more clear as we talk about this. What does the graph of x squared look like? I'll make this a little bigger so we can see it and shoot it down here. Well, let's do just a quick table. First of all, I'll draw a graph. Here's my graph. Here's my table. Let's do x and y. Let's pick numbers that we can figure out this x squared easily. So let's do positive and negative numbers. Let's just go -2, -1, 0, 1, and 2. What is -2 squared?
4.
4. What's -1 squared?
1.
What's 0 squared?
0.
What's 1 squared?
1.
Don't go together. What's 2 squared?
4.
Alright, so if I'm graphing this, it looks like this. Here is -2, 1, 2, 3, 4. -1, 1 looks like this. 0, 0 looks like this. 1, 1 looks like this. And 2, 4 looks like this. If I connect those proverbial dots, this is the graph I get. I'll draw this a little darker. Now this obviously isn't perfect. The graph of x squared is what we call this parabola. It's that U-shaped thing. Okay? Anytime you see a U-shaped thing, you need to recognize that that comes from an x squared equation. Now, depending on what you do to it, I'm just going to show this to you. Let's say I have f of x equals x squared plus 2. You will still get this shape, but it gets shifted because of this number. In this case, it would do what would happen to it. You keep adding 2 and the y. In this case, it would go up 2 things. Why didn't it go up there? Okay, that is the graph of x squared plus 2. of f of x squared minus 2, it would come down here and cross down here at the minus 2 place. You don't need to know that. Sorry, I missed it. You just need to know that when you see a parabola, it's an x squared equation or function. If it's negative x squared, the parabola is just flipped over. Negative x squared is an upside down u. Did I get it? Did I get it? Yes. This is negative x squared. But we don't have negative x squared, so we're just doing x squared. Got that? In review. Because all they're going to do is, in review. Come on, do that. In review. Here's your graph. You see a line like this, it's a linear equation. That is just f of x equals x something. If you see this, you know right off the bat that that is got an x squared in it somewhere, because that's the shape. We call those the parent graphs. The parent, because that's just the general look of it. You know, if you had a number in front of the x squared, it would make it wider, I believe. You know, if you have a number under it, it would make it thinner. If you have, you know, a negative, blah, 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 yeah. Which means you're very excited about this. So you ask, what does the square root of x look like? That's a good question. Let's look at it. The square root of x is this. X and y. Let's just look at some numbers here. Let me blow this up again. Give me some numbers for x.
4.
5. Good. 4, because 4 works out to be 2. 1 works out to be
1.
1. 0 works out to be
0.
0. Negative 4 works out to be
2.
You can't do it. Alright, you're not allowed to have the square root of a negative number, so you're only allowed to keep x positive. Let's do one more. Let's do 9. Square root of 9 is 3, just so we have some here. What is the graph of this? Here's my graph. 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 1, 2, and 9, 3, 5, 6, 7, 8, 9, 3. The graph of the square root of x looks like this. Okay, it has no arrow on the left side going forever because you're not allowed to go forever to the left depending on where it is. But again, if this, if I gave you this equation, the f of x equals the square root of x plus 3, it's going to do the same thing like the x squared thing, that this little thing would move up and be there. If it was minus 2, it would move down and be there. This is the parent, we call the parent of that thing there. And it goes on forever that direction. So if you see something like this, I call that kind of like the upside down Mickey swish or whatever it is. That is the graph of the square root of x. Got it? Right here. There you go. Oh, I hate this. Well, I just said x squared. If I told you to draw a line to the graphs of those things, you should be able to say, oh, this is the x squared graph. Oh, this is the square root of x graph, and oh, this is just straight up x graph. That's all you have to do is recognize their parents. And then last but not least, the absolute value of x. What in the world is that going to look like? Again, if we make a table. Oh, by the way, if this was a negative square root of x, it would just be turned upside down. It would be a mirror image of it. Here we go, absolute value. This should be easy, shouldn't it?
You said it couldn't be negative.
What's that?
You just said if it was negative, it would just be flipped upside down.
No, if the negative was in front of this, right here, it would be flipped over. You can't have a negative inside that, but if there was a negative outside of it, it would be flipped over. Let's go absolute value of x. Let's just do -3, -1, 0, 1, and 3. Absolute value of -3,
3,
-1, 0, 1, 1, 3. Remember, absolute values don't change into their opposite, they just make everything positive. So here is our graph. This is going to be super exciting. I can't hardly stand it. -3, 3, 1, 2, 3, 1, 2, 3. -1, 1, 0, 0. I goofed up a little on that one. 1, 1, and 1, 2, 3, 1, 2, 3. This is what your graph should look like. It is a pointy shaped thing. If it comes to the point, it is going to be the square root of x. Comes to a point, it's going to be the square root of x. This is the parent function, and again, depending on what other numbers are next to it and what they're at, this thing is just going to shift in whatever direction. If it was a negative, was a negative absolute value of x, it's going to go upside down like this. Got it together? Baby, do we ever. Let me see if I can find a question where they asked this. Did they ask us this somewhere? Please say yes.
Yeah.
I don't know if they do. Oh, look at page 182, please. You see the lesson practice letter C. It says match the equation y equals -2x squared to the correct graph. Which one of those would be correct? Knowing again, positive x squared is an umbrella like this. If it's a negative x squared, I'm sorry, it's a U. If it's a negative x squared, it's umbrella. Which one of those two graphs would graph -2x squared? Yeah, the second one, because it's upside down. What else are there? Well, we don't have time to talk domain and range right now. We'll talk about that tomorrow. For tomorrow! We'll talk more about this tomorrow. But what are we going to do for fun, you ask? Which one would you think would be the most fun? There are so many words here.
I don't love the word.
So much words. Let's do
Number 8.
21 through 30. Look at all those words.
Oh. Fun. Oh goodness, that's like my whole essay.
Your whole what?
Essay?
What is that?
You did a diary.
Wait, what?